In this video, I'm going to talk about the ways you can factorize quadratics. So just as a recap, a quadratic is any function that looks like one of these. Y equals ax squared plus bx plus c, or y equals to a times x plus h, x take h plus k whole squared, or y equals to a times x take b, x take c. So these are the three ways that you can have a quadratic expression. Today we're going to just focus on how to factorize quadratics that look like this. And there are three ways to do it. The first way is by using a technique known as splitting the middle term. Splitting the middle term. And this is how it works. Let's say I have a quadratic that looks in the form y equals x squared plus bx plus c. This quadratic would be referred to as a monic quadratic. And monic just means that the value in front of the x squared is 1. As you can see, there is no a term here, so it's just 1. If I wanted to factorize a quadratic that looks like this, I need to be able to find two numbers that multiply to the value of c, and two numbers that add to the value of b. In other words, I need to find two numbers that add to the middle term but multiply to the last term. So let's have a look at an example. If I have the question y equals to x squared plus 6x plus 8, the goal that I have is I need to be able to find two numbers which add to 6 but multiply to 8. And here's a little tip. If you ever struggle on finding two numbers, I would write out all the factors of the last number here. So I would write them out. So 1, 2, 4, and 8. And also minus 1, minus 2, and so on. Now, I can see that two numbers here do work. I can choose the numbers 2 and 4, because 2 plus 4 equals to 6, which is our middle term, and 2 times 4 equals to 8, which is the outside term. And so the way I would factorize this quadratic is I would say y equals to x plus 2 times by x plus 4. And that's how you factorize a monic quadratic using splitting the middle term. Let's have a look at another example. Let's say I have the example y equals to x squared plus 5x plus take 14. So again, because this is a monic quadratic, I need to be able to find two numbers that add to 5 but multiply to minus 14. And the way I'm going to do that again is I'm going to write out all the factors of this last term here, minus 14. So the factors of that would be minus 1, minus 2, minus 7, and minus 14. And the positive versions as well. Now we have to see which one of these values can add to make 5 and multiply to get minus 14. And I've recognized that minus 2 and 7 work, because 7 plus minus 2, or in other words 7 minus 2, that equals to 5, which is the middle term. And I know that 7 times minus 2 equals to minus 14, which is the last term. And so because I know the two values are this one and this one here, the way I'm going to factorize is y equals to x plus 7 times by x minus 2. What happens now if I have a quadratic that isn't monic? So a quadratic that looks like this. In this example, this quadratic would be referred to as non-monic. And the reason it's called a non-monic quadratic is because there is a value in front of the x squared that is not 1. So for example, it could be 2x squared or minus 3x squared and so on. So if we wanted to factorize a quadratic like this, then our goal is to find two numbers whose product or multiply to the value of a times c, and two numbers that add to the middle term. So this one stayed the same, however this one here has changed slightly. Let's have a look at an example. Y equals to 5x squared plus 7x plus 2. The first step is to try and see if we can make this monic, and in this example it's not, so we're going to try and factorize it as is. Now what I have to do is I want to find two numbers that add to the middle term, so add to 7, but multiply to whatever the a term times the c term is. So I want two numbers that multiply to 10, but add to 7. So let's find two numbers that do. And the numbers that I'm going to use are the factors of 10. So the factors of 10 would be 1, 2, 5, and 10, as well as the negative values. That is the factors of 10. And I can see that if we were to look at just these two values here, they would multiply to 10 and add to 7. So the way we factorize now is we need to split the middle term. That's where this name comes from. We need to split the middle term so it looks like y equals to 5x squared plus 5x plus 2x plus 2. And the reason I'm splitting up into 5x plus 2x is because those were my two numbers, 5 and 2. So I just split it up into 5x plus 2x. Now what I have to do is I have to look at the first two terms here. If I have a look at the first two terms, I need to think to myself, what's common? What can I factorize out? And I recognize that I can factorize out a 5x. If I divide this term by 5x, I'll be left with just x. And if I divide this term by 5x, I'll be left with plus 1. Now I have to do the same thing with the other two terms. If I were to think of what I can see common between these two terms, I can see a 2 is common, and I would be left with x plus 1. Now I can factorize once again. I can factorize because the x plus 1 is common between both of these. So that means I can factor out x plus 1, and I'm left with a 5x plus 2. And that's how easy it is to factorize a quadratic using splitting the middle term. This next method we're going to look at is a little bit more tricky. It's called completing the square. Completing the square is only used if you cannot use splitting the middle term. This would be an option I would use or consider after splitting the middle term. Let's say I take an example, y equals to x squared plus 4x plus 3. Or in fact plus 2. First, whenever I factorize a quadratic or attempt to factorize a quadratic, I need to see if I can do splitting the middle term. And I'll cut you some time. However, there are no two numbers that I can think of, no two whole integers that add to 4 but multiply to 2. So then what do we do? Well, we can do completing the square, and completing the square works like this. If we're trying to solve for the x values, i.e. the x-intercepts, that means y must equal to 0. So we first make y equal to 0. Now, please feel free to rewind the video and pause the video if any point doesn't make sense, but this is how you do completing the square. We take this middle term here, the coefficient of x, and all we do is we add half of that b value, so 4 divided by 2, and then we square it. So all I did was I took this b term, 4, I divided it by 2, and then I squared the whole thing. Now I can just copy down the plus 2 from before, but you can evidently see that these two lines are not the same. I've just changed my equation. So what I'm going to do is I'm going to minus away 4 over 2 squared. Now what I can do is I can focus on this first three terms here, these first three terms. If you have a look at these first three terms, you can notice that it's actually a perfect square. And if you don't know what a perfect square is, it means I can square a number or a term and not have any remainder left over. So the way we would factorize these first three terms, and this applies every time you do completing the square, is I can just copy down the green terms, so x plus 4 over 2, and I can square the whole thing. That's how we can factorize the first three terms always. You can just factorize it based on it being a perfect square. Now I'm going to copy down the rest. I can copy down the plus 2 from here, and I can do the expansion of this. 4 over 2 is just 2, and if I square this, that would just be 4, so minus 4, and that simplifies to minus 2. Now what I can do is I can solve for x. If I want to bring this minus 2 to the other side, I have to add 2 to both sides. So 2 equals to x plus 4 divided by 2 whole squared. Now if I want to get rid of this square, the opposite of squaring is square rooting. So I know I have to square root both sides. The plus or the minus of square root of 2 is the same as x plus 4 over 2. And 4 over 2 is the same as 2. Now if I want to solve for x, I can move this 2, because we're adding it to this side, we can minus 2 from both sides. And so what I have left is x equals to minus 2 plus or minus the square root of 2. What happens if we have a non-monic quadratic? Let's say y equals to 2x squared plus 6x plus 3. Well, the first step I would still do is try to find two numbers where I can use splitting the middle term. So two numbers that add to 6 and multiply to 6. And I can't think of two numbers. Let me know in the comments if you can, but I can't. So I'm going to use completing the square. So the first step in completing the square is always make it monic. So I'm going to divide every single term here by 2. And that would simply be x squared plus 3x plus 3 over 2. Now what I want to do is exactly the same thing as before. So follow along. I copy down the first two terms, and I look at this b term here, the coefficient of x. In brackets, I will take that b term, I will divide it by 2, and then square the whole thing. Then I can copy it out, the other term, 3 over 2, and you can clearly see I've just randomly added this extra term here. And because I can't just randomly add it in, I'm just going to take it away as well. Because I halved and squared this b term, I can have a look at this term here and this term here, and I can notice that the first three terms here are factorizable into a perfect square. So I can rewrite it as y equals to x plus 3 over 2 whole squared. So that's what these three terms become. Then I can copy out plus 3 over 2 minus 3 over 2 whole squared. And just a little mistake I made, you always have to make y equal to 0 when you're factorizing. Now I can simplify this last term here. I can say that 0 equals to x plus 3 over 2 whole squared, and this squared is just 3 squared over 2 squared, which becomes plus 3 over 2 minus 9 over 4. I can simplify this into minus 3 over 4. Next, I can move this 3 over 4 to the other side. Next, I can move this 3 over 4 to the other side, and it would be 3 over 4 equals to x plus 3 over 2 whole squared. And I can square root both sides. So if I want to square root both sides, I would get plus or minus the square root of 3 over 4 equals to x plus 3 over 2. Lastly, I can move this 3 over 2 to the other side, and I'll have minus 3 over 2 plus or minus the square root of 3 on 4. And if I wanted to simplify one more time, I know that 4, the square root of it, is just 2. So I know that minus 3 over 2 plus or minus the square root of 3 over 2 is x, which is simply minus 3 plus the square root of 3 plus or minus the square root of 3 over 2. And that's how you do completing the square with both a monic and non-monic quadratic. Now, what happens if we have a quadratic where the terms are so big or so small, or we have decimal values, and it's really impractical to use either one, either splitting the middle term or completing the square? Well, luckily for you, there is actually a very nice formula. If I have a quadratic where I want to factorize it, but the numbers are too annoying and too large for me to factorize using the first two techniques, I can use the quadratic formula. The quadratic formula is simply a way we can factorize these quadratics and we can find the two numbers without having to do any algebra. And the formula for it is x equals minus b plus or minus the square root of b squared take 4ac all over 2a. And the a, b's, and c's come from this question here, this example, this form of a quadratic. So let's have a look at an example, and I'll have this formula on the side for you to refer to. Let's say I wanted to factorize y equals to 3.5x squared plus 2.7x take 6. Now, this example, I cannot think of two numbers that add to 2.7 but multiply to the outside terms. And I also cannot be bothered to complete the square. So we're going to use the quadratic formula. The quadratic formula says that if we take this to be a, this to be b, and this to be c, we can solve it by saying x equals to minus 2.7, because that is the b term, plus or minus the square root of 2.7 squared, take 4 times minus 6 times 3.5, divided by 2 times 3.5. And if you work out what this value is, you'll get 2. 1 because you have to plus, and 1 because you have to minus. And once you work it out, you will know that this here is a solution to this quadratic. And I've just worked out what the roots are, and your value should be that x equals 0.979 and x equals to 1.751. And that's how you factorize quadratics, using splitting the middle term, completing the square, as well as the quadratic formula. If you enjoyed this video, please make sure to like and subscribe, and leave a comment on what topics I should cover next, as well as if you have any questions on what I taught in this video. Thank you.